Hello everybody and good afternoon. I hope you can hear me okay. My name is Ona Mahoney and I'm Cluster Manager with IT Cork, so it gives me a great pleasure to welcome you all here this afternoon. Now, this afternoon's workshop is brought to you as part of IT Cork TechFest, which is a week-long festival of tech. It's 5 keynotes, 5 panel discussions, 5 tracks over 5 days, and 1 special members-only event, which is due to be announced shortly. A big thank you to our sponsor, IT Cork SkillNet, who are also our learning partner for IT Cork. So to find out a little bit more about IT Cork and IT Cork SkillNet, you can go to our website, www.itcork.ie. You can also go to see the full schedule of events for the week on our website, which is www.techsummit.ie. Now, some members are still inquiring about tickets. Tickets are still available for members. If you want to register for some of the webinars and workshops throughout the week, just email us on admin, that's admin, at itcork.ie. So now, this afternoon's workshop is going to be very interesting, and we have 2 excellent presenters in Nikos Chalikias, I hope I'm pronouncing that right, Senior Embedded Systems Engineer with Nimbus, and Brian Cahill, Business and Research Development Fellow with Nimbus Research Centre also. So they're going to talk all things IoT for your business. Before we start, we are recording the session and we will make it available over the coming weeks for our members and the general public. You will have an opportunity to ask our presenters some questions. We're going to leave that till 1:45, or sorry, around 2:45, 2:50, just at the end. So you can use the Q&A tab. You'll see it down at the bottom of your screen. So please do interact. We'd love to hear your questions. So without further ado, I'm going to hand you over to our 2 panelists from Nimbus. So Brian and Nikos, if you could turn on your mics and your cameras, please. And I will quietly slip into the background now until our Q&A panel discussion starts. So over to you guys, and thanks again for making yourself available for this workshop.
Okay, hello everybody. My name is Brian Cahill, and I'll be handing over to Nikos now momentarily. So just looking at the participants list, we're not going to name and shame anybody, but it's so nice to actually see some familiar faces on the list tuning in today. I suppose like a lot of the people that I know on this list have been into us many times and have availed of the services of Nimbus, which are obviously quite technical and will cover a large sphere of skills, from software development to hardware development, middleware, user experience, and of late we're delving into the whole area of mixed reality, and data analytics is front and center at the moment. One thing that's really nice about Nimbus sometimes is that we're really a barometer for the economy at the moment, and always have been. We are extremely busy, which means industry is extremely busy, and that can only be a good thing. I think we've actually changed the way we operate. We, like many on the call, have done extensive travel over the years to meet various partners. We've cut all that out now, and things have become a little bit more efficient and quite sustainable. So we've had more time to actually do the work on the ground, which is great. Now, today's presentation will focus primarily on one particular project that Nikos and team have been working on over the last number of years that have benefited from the Enterprise Ireland Commercialisation Fund. So this particular fund is open to industry as well to come into a knowledge provider like ourselves in Nimbus and let's say play the role of inventor, to see if your ideas can see the light of day and realize a very unique contribution to technology. The challenge at the end of these projects is the commercialization piece. And again, that is where we actually look to you guys to come in and see, okay, does this particular technology strike a chord? And if it does, how can we actually make it a global success? So as I say, myself and colleagues, our front door is virtually open all the time now. And if you have any queries on any of the financial opportunities in Ireland, please just ask. All you do is just Google Nimbus and, or CIT, and you won't be long falling in our direction. But without further ado, I think what I'll do is I'll bring on Nikos now just to bring you through. And this is a look and feel of a typical project, certainly in the years of the life of Nimbus, that's for sure. And I'll take it away there, Nikos.
Okay, hello, I'm Nikos Chalikias. I will present Mblox. Should I share my screen now? I guess, yes.
Yeah, that would be great.
Screen one. Share. Yes, okay. I guess it's good now.
Yeah, that's perfect, Nikos.
Okay, thank you, Brian. So this is about Mblox, our modular low-power IoT platform we developed in Nimbus the recent years. This is a snapshot from our web page, a modular platform for IoT devices. So let's start. Why did we start all that huge effort? What our motivation was? So I have two slides on this. This is the elegant one, and the next one is the ugly one. I prefer the ugly. But on the elegant now, we wanted to have a good roadmap to commercialization. That means to be able to go to production in an easier way, and also to deliver to Nimbus clients, which is not always production. Okay, flexibility, compatibility with existing firmware platforms, reusability was important, development time the most important, and of course we wanted to be aligned with what happens out there. I mean, ARM, low power, wireless SO networks. And number 7 I have there in blue, to build background IP via standardization. And we come to the ugly one, which is the good one actually. So the question is how we avoid the people after us, after we develop everything we develop, embedded systems and IoT and boards and systems, to treat our work like this, to be useless to them, in other words. So how we avoid that? What is the answer? This is what we try to do with this project. We try to find a good answer to this question. So we set up our design principles, modularity in a brick style. Obviously, nobody throws away its Lego. Lego are always useful. This was our goal, to have our boards as useful as Lego. We wanted to have performance scalability, to be able to deliver simple use cases or very complex use cases with the same platform, the same boards, not having to redesign again and again. Battery operation, because of our Nimbus Center focus on wireless sensor networks, battery operation was important. IoT has a lot of wireless devices working with batteries. And of course, the functional scalability, to be able to deliver simple things or complex things, again, with the same platform. We created a lot of boards. Standardization worked, supported us on development. So during our development, our principles seem to be working even for this development. So that was to support the developers and the developments after this, but it was self-sustainable. I mean, these concepts worked. And that's why we were able to deliver a lot of IoT devices. Am I going too fast? Or am I going too slow? Brian?
Just perfect, Nikos.
Okay. So our standardization was simple. One size, 33 by 43 millimeters, 24 pins, simple functionality, so was easy to use. This is not always the best case, but we come to our next slide. So, broad range of use cases that we can support. Wi-Fi wireless sensors, LoRa wireless sensors. In the middle, we have a pure microprocessor board without any wireless capabilities. Radio communications is important for IoT because IoT is a lot of sensing, and most of the sensing has to be wireless, no batteries, just little nodes spread. So we had and we did, and we supported many technologies. Our featured one is LoRa and LoRaWAN, but 15.4, Bluetooth is flexible, and more. For the sensing, for the little sensors we use, we created a more granular, more detailed modularity. But this worked, but this also reveals the disadvantages of this version, the 24 pins version, which is the slide after that. So we do have wide software compatibility, the embed and the RTOS, Cahill and CMCs because we work mostly with ARM. The academic wireless sensor operating systems, TinyOS and Contiki, because of our N-mode development with MSP430 and other TI. Then we had to create a new version, the Mblox Pro version. This is our public wiki. We have everything there, presented in a structured way. So, why Mblox Pro? I'm reading the yellow box. So, no cables. We didn't want any cables. The 24 pins were nice, but it was very, how to say, maker style. Makers don't mind to have cables. Actually, they like cables. But to have something more mature, we should avoid any cable. And not designed for production. What does it mean? This is important. It means that our board should be able to go to production as a plug-in to a bigger motherboard. This is big responsibility and not easy to design, but we felt that that was the best way to go for our version 2. Of course, having that scalability give us the capability of working with simple and much more complex designs. We focus mostly on ARM Cortex processors, from small ones, M0 to A8 running Linux. So we can cover the whole range from few megahertz processors to 1 gigahertz Linux processor. It is the bicycle to Ferrari example. And 4 kinds of boards. Host boards, which are boards only with microprocessor. Peripheral boards without microprocessor, mostly with sensors. Application boards that they really deliver a project. And development to support the development process. So our form factor, we kept the same 33 by 43 dimensions for our boards, but we changed the connectors. Now we have on this platform 240 pins. Probably this is one of the most important slides here. With those 3 topologies, we can support everything. The wireless host boards at the bottom right, with these ones standalone, we can support a huge range of wireless sensors and wireless sensor networks and IoT use cases. The host board plus peripheral expands those wireless capabilities. And the big one at the left, the application motherboards, can support virtually anything. And it doesn't have to be low power, it doesn't have to be wireless, it can be embedded systems, which it's actually wider than IoT. So this is a sample of our new Mblox Pro. These are 10 from our first boards, but there are more now. I will discuss a few of these boards. These ones are standalone wireless hosts, lower on the left, Bluetooth low energy on the right, and a Wi-Fi. All of them have some common features. The crypto element to support cryptography and security. They do have one wire E2PROM to support electronic datasheet, so we can have a description of the capabilities and the interfaces of the board. So when you try to plug and play, so you automatically exchange information. They all have JTAG connection for the development. They all have temperature and humidity, light sensing and acceleration sensing. All of them can support environmental sensors. At low power, you need to replace the battery in 1, 2, 3, 4, or 5 years, depending on the scenarios and the protocols. These ones, the microcontroller host boards, they don't have wireless capabilities. and they can be the heart of anything industrial. We cover huge range of performance. The one at the right is 1 gigahertz, Cortex A8, can run Linux. The one on the left is 100 megahertz board. A development support agent. And now some use cases which are more interesting. So this is an environmental indoor sensor, standalone, a host wireless Wi-Fi. Notice that we need a supporting interface to mechanically match that enclosure. The same here, we need a mechanical matching. This is the same box, different color, but we have a different technology for the radio. This is LoRa 1. And for some use cases, the projected battery life can be 10 years, but this depends again on the usage. So now we have a little application motherboard, and this is important. This application motherboard can accept any host or wireless host Mblox, and can support. So this way, changing the radio host, we can have totally different protocols and wavelengths. This motherboard mechanical interfaces to a specific low-cost enclosure for indoor sensors. So here we don't need any mechanical interface to the enclosure. The motherboard matches the enclosure. In this one, we have a LoRa sensor, and we have added a little sensor board to expand the sensing capabilities, and the motherboard itself provides PIR motion detection, a sounder to hear beeps and sounds, and the same motherboard, no, that's okay. A different use case, a motion control for a 3D printer. So we have an Mblox Pro motherboard and an Mblox Pro host. We have tested this in our motion control test bed of Mega Delta. Okay, and how do we develop firmware? Maybe this is even more interesting. So I'm attempting a small introduction to flow-based programming and diagrammatic programming. So embedded software development is usually created writing code. But this is not the only way. There is another paradigm known as flow-based programming, or another one known as function blocks in PLC domain. There, the function blocks are visually connected with wires to compose the software design. We don't need to write code. Of course, we do have code inside the blocks, but once we have the library of blocks, we just connect them and we create what we need. We developed Mblox Studio to use this concept, and it's successful. It works for our Mblox. It works for any embed compatible board, which is practically thousands of different boards. And our recent version can work even with Arduino. So our Mblox Studio works with Mblox and non-Mblox embedded boards. So this is a synopsis, an overview, a graphical environment. We create applications without code. We are using an underlying kernel And we have a server that supports contribution. What is this? Users can contribute nodes. So if I create, for example, myself 5, 10 nodes, I can use 100, 200 other people have created. So I'm not dependent only on my nodes. So this is a contribution management system. The workflow. How do we work with the Mblox Studio? We pick from our node repository the nodes that we need, in this case, just 2 nodes. We create a diagram, we press the button, and code is generated. That's simple. This is a real-life board example from our camera development. This design controls, is there anything wrong here? No. Okay. Our system controls the camera, the lighting of the camera, which is multicolor, controls infrared, controls shutters, controls electronic liquid lenses, measures temperatures, currents, power, voltages, creates sounds and switches on and off loads to save power. That was a real project that we had delivered with normal coding, and we used that hardware platform to compare the development with our Mblox Studio. So this is a schematic, and this is the result. When you press the button, this is what is created. That design created 68 lines of code. And this code is very easy to read. We have the first section on top. What libraries did we use? The next section is the list of all the nodes and the parameterization for every node. The next section is the connections, and this represents the diagram and the wires in the diagram. And then the little one is the main loop, which just initiates the kernel, and it's empty. And users can add user code there. Another design, this is from our previous iteration IDE. We don't use that anymore. This is a 4-bit binary counter diagram. And when we press that button, this is the code that is created. Again, the same structure. The libraries used on top, the list of nodes, and the list of connections, and the main loop. Yes, but what do we do if we don't like, or if we don't have access to IDEs or schematic capturing tools? We can create diagrams without drawing anything. We could create diagrams with ASCII notation. So we have defined and created ASCII notation interpreter. This design here on the top, okay, always the diagram is easier to follow. We have a design with 2 blinking LEDs, N8 and N9, the ones called blink. We have a timer ticking at 1 second, I think, 100 milliseconds. And this triggers a temperature sensor and a power, current, voltage, and power sensor. So this exact diagram is represented at the bottom side of the black box, where we have this purple hash diagram. It's exactly the same, but written with ASCII notation. So ASCII notation is not code, it's not diagram, but it still is diagrammatic. And it's much more economic than writing pages and pages and pages of unstructured code. So our translator can read our ASCII notation, and to support developing this way, we have created an extension for Visual Studio Code editor that highlights ASCII notation. Any file that has extension NBLS can be highlighted like that. So the kernel. Graphical is nice, but graphical is not the target. What makes Mblox Studio powerful is the kernel and the concept behind the kernel. So I repeat here the workflow. First, we collect the nodes we need. We create a diagram. We press the button, we generate the code. Then we have to compile. When we compile, the executable file contains the nodes code and contains the kernel. The kernel manages all the timing of our application. I have a few slides explaining the kernel operation because it is critical. So I have this one in simple words and I have the next one in very simple words. I'll jump to the more simple one. So assume we have a 1 millisecond kernel clock, which we do have, and assume it is sounding tick-tack, idle, tick-tack, tick-tack. So it ticks every 1 millisecond, but it has two parts, a tick and a tack, for simplicity's sake. So in the tick part, the first part, the messages immediately cross the connection line from the send box to receive box. In our diagram here, from GPI box pin 1 to GP out box pin 1 again. So if we have more connections, all these messages are crossed through the line at the tick part. Then we have the tack part. This is the processing. The nodes process the messages and create something. This something can be an LED blink, can be start or stop a motor, or anything. And all nodes are executed again one by one. So in the tick part, we pass all the messages. In the tack, we process all the messages. If any messages are created, they are waiting for the next tick to cross the connection line. And then we have the idle part, the part when it's between every tick-tack, the parts when we do nothing. In normal operation, there is always some time between these 1 millisecond frames, and this is healthy. And in a low power system, this idle time should be the sleep mode, the power saving mode. This is the time where we don't spend our battery. And this makes our system work for a long time with the battery. Here I have a more complex design of the same mechanism, but I think it's better to skip. Okay, stay a few seconds. Maybe some people of the audience would like to see. Okay, that's it with the kernel. What's happening here? Okay, the server, the Mblox Studio server. So we wanted to support contribution. We need a contribution model, otherwise our studio cannot grow. The Mblox team can create 10, 20, 100, 200 nodes, maybe, but we don't want to end there. We want to have thousands of nodes. And our server supports contribution. Every user can log in, can register, can create and register his or her nodes. And those nodes can be used from the overall community. Some real-life use cases. That was with the studio. Some real-life use cases of Mblox to conclude. That was an older project made with Mblox to monitor fats in grease traps for restaurants. This one again with wireless Mblox to manage the environmental parameters in public libraries. This one is installed in Torino in Italy, sensing CO2, volatile organic components, light, temperature, its own battery. That one was an environmental monitor device we installed in River Liffey for 9 months, a very successful project. We were measuring depth, turbidity, different kind of temperatures, tilt and humidity, vibrations and light, flow, and the magnetic field. It was based on 3G and LoRa. What is this doing here? Yeah. Okay. We are ending now. So what did we do with Mblox? We created a modular IoT platform. Our design paradigm is based on modularity and performance and functional scalability. We have an easy-to-use software platform, the Mblox Studio, and we demonstrated the usefulness in a range of real-world cases. What we do next, we're extending the hardware platform. Some hot topics on IoT, battery-powered edge computing, not easy. We want to increase our processing capability for machine learning in low-power wireless sensors. And of course, we have to add application motherboards. And for the studio, we are creating higher integration nodes like PID in one node. And we are adding and testing now Arduino compatibility. This will give us a better, how to say, user base. Mblox project was supported by Enterprise Ireland. Thank you, Enterprise Ireland. And questions, please.
Okay, Nikos, so I know Noel Delan is online, and he just asked a question: is this a commercial or OSS platform? And how does one get access? But that's probably a bit premature now at the moment. This is actually not on the shelves as yet. And what's the gap that needs to be filled to get this platform from where it's at the moment to on the shelf that anyone can use it?
Thank you, Brian. This is not a commercial product yet. The development phase just ended last month. Our next step is commercialization. But there is public access. One of our wikis is here in this address. We have more. But probably the easiest to access is this one, simplest, and gives links to everything, all our wikis and all our repositories. Not everything is public. We don't have a way to sell those boards from CIT. CIT cannot do that. But very soon we will have a better answer.
Okay, another question that popped in during your talk was from Alan Cooney, actually, and basically he was just asking, what industries do you envisage being the first to take advantage of Mblox? But I know that I know it's partly privy to conversations, but like there's certainly an educational platform application here, and I know that from industry. There's a heavy plant manufacturing company that approached us about rapid prototyping very quick and easy deployable sensors. That's just two examples. Nikos, do you have any other comments to make on that question?
Yes, I have some comments. The first comment is that the platform is very wide. It can be used everywhere. Number two, Industry 4 and Industry Automation probably will be the first that they're going to use this commercially. Wireless sensors is the third.
Okay, that's great, Nikos. What I might do now is I might just actually take the floor for a few minutes, Nikos, if there isn't any further questions. And of course, if there is further questions, please post them up on the Q&A board. We'll pick them up and we'll answer them during this time. I just wanted to talk a little bit about funding, and I also wanted to talk a little bit about how to cleverly utilize the third level sector to harness some funding or answer some technical questions that you may not have the bandwidth to address with your current
Brian, sorry,
yeah.
This is Owen here. Can I just ask Nikos to stop sharing so we can see the screen again, please?
Okay. I'm going to actually just activate my camera here anyway, guys, just so you can see. And what I'll do is I'll share my screen. Okay, let's just go in here, share that. Okay, so I just assume everyone can see that there now. Okay, so you know, sometimes in all the years I've been doing, like I've worked in industry and academia, about 50-50 split of my career. Like I would have been a 90s graduate, you could say, from electronics and software discipline. So funnily enough, you know, we still get that, let's say, shyness from industry on, let's say, entering the doors and corridors of the third level sector to see what they can actually squeeze out of it. And I'm a firm believer of utilizing that asset that the country has to the maximum and selfish, to the maximum of your selfish, let's say, ability within the company. So what I mean by this is that first and foremost, what's free from the industry at the moment that you might be able to address. So everyone should understand that in any typical academic year, there is a hunger for industry projects. The model of funding today in the academic sector is industry contribution to release an academic funded grant, either from SFI, from Europe, or whatever. The model always involves industry. So what can industry get that's free first? Let's start off the low-hanging fruit. So just say I have a company and I'm developing some service, but I just have 2 people or maybe 10 people. I don't have time to actually address new innovation. One thing I can certainly do is go down to my local third level institute, one of which are many right across the country, and propose a number of projects where I could actually co-supervise a student cohort to address that particular issue. You might come in prior to September, and following that, you can get your answer possibly by the following June, which you babysit a cohort. There's a number of advantages of that. If you're in a position of recruiting some top candidates for your company at entry level, that's one way of actually getting your dipping your toe into that pool. So that's the first thing that I would advise. The second thing then is the country has about 15 technology gateways. The Nimbus Research Centre has one such gateway, the Nimbus Technology Gateway, of which myself and Nikos are employees. And right across the country with 14 others in CIT, and soon to be the Munster Technological University, we will have 2 others, Kappa, who deal with the photonics technology solutions, and IMAR, based in IT Tralee, who are more mechatronics and RFID related. So each of those entities are good to approach to talk about funding opportunities in the sector, how to get their hands on specific skill sets that may just get you out of a bind in relation to progressing with your innovation or realizing alternative income streams. There's a number of advantages in liaising with these people. The majority of the industry technical gateways across the country, obviously we're all affiliated with Enterprise Ireland, but we have very experienced staff, and the majority of which are ex-industry. And we can certainly add value-added ideas to possibly your entry innovation. You present us with an innovation idea, we can certainly add value to that. The process is quite simple. The first thing we always do is we put down a non-disclosure agreement on the table so everyone is comfy in sharing ideas. The second then is we'll look at maybe the criteria and the perfect fit for funding for you, just to take the sting out of your R&D costs. Now, everyone on this call should be well aware that any contribution you make sometimes to an R&D program like the ones I'm just going to talk about, you do qualify for 25% tax credits. So that's, again, another mechanism to lower your costs. Entry-level funding of choice is obviously the innovation vouchers. Majority of people at this presentation would have leveraged such vouchers. In Nimbus, we will do the applications, and we will work towards getting you a solution through that particular program. Every company is entitled to 2 standard vouchers, which are €5,000 each, and 1 co-funded voucher, which is a matching voucher up to the value of 5,000. So 5,000 in gets you 5,000 back from Enterprise Ireland. Or if you can manage it, Enterprise Ireland do offer a suite of 3 co-funded vouchers as opposed to 2 standard and 1 co-funded. So just bear that in mind. Another unwritten piece of knowledge to do with the voucher scheme is that a number of companies can come together and contribute a voucher to one particular technical cause. So there's a couple of projects that I've been trying to actually try and get off the ground over the last number of years, where, let's say, a donation of a voucher to a particular cause would actually realize something special. So again, it's not documented, and I don't really have such many examples of that, but it is supported. Outside of the vouchers, well, it's worth also pointing out before I leave the vouchers is that anything that's developed in an innovation voucher is the property of the beneficiary company, so that's well worth understanding. Outside of that then, we've got the Innovation Partnership program. So this is a program that's has probably got the best deal in town in relation to R&D funding from Enterprise Ireland in particular. Depending on the size of the company, a small to medium-sized company can probably enjoy anything from a 20-80 to 30-70 split in funding from Enterprise Ireland. Usually if there's an industry contribution, the contribution is made usually in 3 tranches over the course of the development project. So again, it just takes the financial pressure of what needs to be paid by the industry partner. And the IPP program is preceded by a technical feasibility. So Nimbus, for example, would use this to scope out the project, probably make a start on the design and the system architectural requirements of the project. From there, then, we've got a plethora of options. And this particular page here in the Nimbus page focusing on funding would give you some links to some of the programs that are available. The Agile Innovation Fund is generally a 50-50. SFI generally offer a 50-50 as well. And it's just worth noting some of these programs. Then we venture into what's on offer across the EU. So again, we are not seeing too much, let's say, of benefit more than 50-50 split on some of the programs that are on offer from the EU, but generally speaking, they are worth taking note of. Now, and again, for dealing with the academic sector, we can take handle of a lot of the paperwork that's involved in these programs, such as the applications, and I think Nimbus has been pretty good to assist our industry partners on the application side. That's really about it. So the message I'm trying to portray today is get familiar with your technology gateway, get familiar with your local third level entity, and also get familiar with, let's say, what courses you have on offer that actually strike a chord with your service offering or your solution or whatever, because they are a cohort of future staff for your company going through those courses, plus they could be armed with maybe a final year project or a minor thesis topic proposal from you as well. That would get you closer at no financial risk whatsoever to the company. Okay, guys, that's really about it from me. So I'm going to see if we have any questions. I'll stop sharing here now. And just see if we have any questions in from the cohort. And I think we're looking pretty good. So if anyone has any questions, please shout or write it into the Q&A that's provided there.
Thanks, Brian and Nikos. And just while we wait, if we any more questions from attendees, Brian, I might just ask you for a company that may not have explored, significantly R&D or any of these innovation supports. Where do you think is now, I suppose, a good time to start when companies may have a little bit more headroom and to invest, in exploring new research areas?
Yeah, I want to tell you, I'm just sharing again, just the browser here on my machine. So there's to be honest, what's been paying the bills a lot from the technology gateways up in other countries has been Enterprise Ireland funding, really. And essentially, the innovation vouchers are a really useful mechanism for companies to actually target that that idea that they just don't have time to cover at the moment, or might be completely an off-the-wall side of their business offering. So I would suggest companies are familiar with the innovationvouchers.ie webpage, which is quite useful. In addition to that, again, we've got other online repositories worth looking at. So we talked today with Nikos about a project that was funded through the Commercialization Fund. This is actually advertised and marketed as a Commercialization Fund for third level researchers. But there is a caveat here to invite in industry inventors to participate in that project. So that's also well worth looking at. And funding for typical commercialization, the first phase or even two phases of that particular project could be anything up to about 300, 350 euros, which is great. And then we have the Innovation Partnership Program, which is again heavily utilized by industry currently, and well worth looking into. And again, I often feel that this is the best deal in town, because the majority of the companies that we deal with are certainly benefiting by just 20% contribution to these projects, and that's well worth doing. But I think every company should really have the radar open in relation to who out there can actually take care of investigating new ideas that might realize new income streams for the company. And there's about 300 of us involved, staff involved in the technology and gateways up and down the country, with different skill sets and different let's say areas of expertise, and it's our job to actually flesh out these ideas for industry. And Enterprise Ireland look at that as a service to, let's say, enhance the offering of Irish companies. But that cohort of staff do have certainly good ideas to add value to those that we get from industry. So doors are always open. And again, I know that I have a slide here on technology gateways, but what you can do is just Google technology gateways and you'll get the 15, a listing of the 15 technology gateways that are available up and down the country.
Thanks, Brian. One other question that I'm sure industry in particular might be interested in is IP and the management of IP as a result of these research projects. Does this vary from gateway to gateway, from project to project? Is there a standard approach?
No, there's, we all read off the same IP hymn sheet right up and down the country. So again, a Google search on the IP protocol of the country will soon lead you to a document that outstands the law of handling IP in this country, and it goes into the granularity of what the industry rights are when it comes to various programs. Now, for innovation vouchers, any IP, if you're lucky enough to stumble upon IP during an innovation voucher stage, and the funding there is quite small, but you never know, it has happened in the past. All IP on that program is owned by the company. For the Innovation Partnership program and any other program other than vouchers where you're actually benefiting by a grant from the state, you will eventually be going into an exclusivity agreement to utilize the developed IP on those programs. So that's something industry can be worried about. But I suggest that everything is okay. The state is behind you. They want to see you doing well, and they want to copper fasten the safety of this IP and keep it within the country. So I think that's the idea behind all that. Now, as a rule of thumb, if you pay for 100% of the R&D, you own the IP. That's just the bottom line. And sometimes, if you realize you actually and you can afford it, to develop something extremely unique, and you pay for all that IP. That IP, once it's developed, maybe worth more than actually what you paid originally to get that developed. So that's all that needs to be taken into account. In Nimbus, we have an innovation, or in CIT, we've got an innovation office. Those guys know the A to Z when it comes to IP management. So again, there should be at least one meeting a year with those people by industry, just to get the lowdown on the latest and greatest with IP management.
Excellent. I don't see any more questions coming in. So I think we'll just wrap it up there. We're just a couple of minutes off 3 o'clock. So Nikos and Brian, thank you very much for your time. I'm sure you're contactable by people that have dialed in this afternoon that might be interested in hearing more. So I think we'll just wrap it up there. Big thank you. Tomorrow, for those of you that are interested, our track tomorrow is the cyber track. So we're starting bright and early again at 9 AM in the morning. So please dial in. We have a very exciting keynote speaker in Rick Ferguson, and we will have a cybersecurity workshop in the afternoon as well. Okay, so thank you very much, and we'll see you tomorrow, hopefully. Thank you.